Jai Hind everyone, myself Dr. Neeti Bansal, and today we are going to begin a new lecture in the complex lecture series on IoT. So the topic for today is IoT networking, and we will discuss the networking architecture for IoT. What is its need? What are the various layers of the IoT networking architecture, and what are the various application areas for it? So beginning with the need for it, the architecture of IoT networking is crucial to ensure that IoT devices can communicate effectively, securely and efficiently. So basically, for the efficient communication of various devices of IoT, it is very necessary that at the first step we define a particular networking architecture for IoT. This architecture defines how the data is transmitted, processed and managed across different components of the IoT ecosystem. So from this line it is very clear that how the data is being communicated through various layers and various components of an IoT ecosystem. It is defined by the networking architecture of IoT. So IoT networking architecture, it comprises of various layers that work together to connect the devices, transmit the data and enable actionable insights. Okay, so basically what is actually a networking architecture for IoT? It is defining the flow of data throughout the entire architecture of your IoT. Now we will discuss the key layers of networking architecture of IoT. The very first layer is device layer or the perception layer. So in the term Internet of Things, when we say the term Internet of Things, the devices, the intelligent devices, the smart objects, the sensors, the cameras or whatever the smart objects, the intelligent objects are there, the things are there, they are comprised at the very first layer, which we call as device layer or perception layer. The device layer includes all the physical devices and sensors that collect the data from the environment. So the major role of this layer is to collect the data from the environment. This layer serves as the foundation of IoT architecture. This will be the basic layer, capturing real-time data from various resources. So basically, the very first layer called the device layer or the perception layer, whose role is to collect the data from either the environment or from the physical object with which they are attached. So it may include sensors like we already know there can be a wide variety of sensors including temperature sensors, humidity sensors, motion sensors, etc. These components may include actuators, motors, light switches. So here the question arises that what are these two components? Sensors are the ones which are collecting the data from the environment. Okay, they are converting this data into electrical signal, and actuators are doing the opposite action. They are taking the control action. So actuators are converting the data, the insights into actionable results, into some action, into some mechanical motion. Next, it will consist of embedded systems like Arduino and Raspberry Pi. So sensor is the one which is collecting the data and actuator is the one which is taking the control action. But what about a system that is processing this data so that it can be converted into some meaningful insight? So that is my Arduino or Raspberry Pi microcontroller board, which acts like the brain of this entire system. So there is requirement of an embedded system which can work like a processor, which can be called as a brain of this entire system, taking the data inside, processing it and producing some meaningful result. So we have three major components like this: sensors, actuators and embedded systems which may control microcontroller boards like Arduino and Pi. What can be the functions of this layer? First, we have already discussed data collection from the environment. This layer will collect the data from the environment. Initial processing and filtering of raw data. The raw data that has been collected will be initially processed and filtered, and direct interaction with the physical world. So this is the layer which is directly connected to the physical world, to the virtual objects. Okay, so this is device. First layer is device or perception layer, comprising of sensors, actuators and various embedded systems, and the major role is to collect the data from the environment and perform some initial data processing for the raw data. Moving on to the next layer, the second layer is connectivity layer or the network layer. So the data has been collected. It has to be propagated further. How it will be propagated further? Through the various networking components. So here comes the networking layer or the connectivity layer. It handles the communication between whom? Between the IoT devices and other components of the architecture. So to connect or to transmit or to transport the data which has been collected by the things, by the sensors at the perception layer, we need some connecting devices. We need some networking layer. It includes the protocols and communication technologies that facilitate data transfer. So data transfer को facilitate करने के लिए जो भी protocols and technologies आपकी required होती हैं, they all will be covered up in this second layer. So it can include wired or wireless connections. There can be two types of connections, either wired or wireless. When we talk about wired connections, Ethernet and PLC. PLC stands for power line communication. So Ethernet and PLC are the common solutions when we talk about the wired connections. And we talk about the wireless connections, we can have various protocols like Wi-Fi, Bluetooth, Zigbee, LoRa, which is termed as long range, and cellular. So these all are the protocols which can be used for wireless connection between devices. Then we have another important component of IoT called IoT gateways and routers. So IoT gateway is just like a bridge which is connecting the data collected at the first layer to the other higher layers. IoT gateway acts like a bridge, plus it also performs the necessary protocol conversions which are required between two different layers, between two different type of devices of the IoT ecosystem. So what are the various functions of this layer? It transmits the data from the devices to the cloud or the edge servers. Okay. So at the very first layer, we were having devices or sensors, actuators like that. They collect the data. Second layer is collecting the data and transmitting it to other higher layers, that is cloud, servers, etc. It ensures secure and reliable communication through various networking protocols. Various networking protocols are used here to ensure a very efficient flows of data between various devices. It manages the data flow, error detection and correction. Moving on to the third layer. So at the third layer, we have the edge layer, which is also called the processing layer. So the role played by this layer is also very important because it is related to data processing. The data which has been collected, now the thing is we have to process it so that we can draw some conclusions over it and so on. So the edge layer includes devices and servers that perform data processing, and this data processing is performed close to the devices that collect it. That's why we call it edge processing. So this data processing is performed closer to the data source rather than relying on entirely on the cloud computing. So this layer will aim to reduce the latency, enhance security and optimize bandwidth usage. See, what is happening here is the data has been collected at the first layer. It has been transmitted or communicated by the second layer, networking layer. Now, if we transmit this entire bulk, huge amount of data to the cloud directly, this data will be processed on the cloud obviously. So cloud computing, the role of cloud computing or data processing at the cloud will be very huge. Uska role वहाँ पे बड़ा enormous हो जाएगा. वहाँ पे we have to wait for the entire data to be loaded onto the cloud. Then some processing will take place, some algorithms of ML will be applied over it, and then some decision will be taken. Now, what is edge computing or edge layer? The role of edge layer. Understand the role and importance of edge layer. So, if we are performing some data analytics, some data processing, we are segregating the data before it reaches to the cloud, then it is called edge computing or processing layer, the function of the processing layer. This is the initial data processing which is performed very close to the devices which collect the data, and instead of burdening the cloud with all the data that has been collected, we are reducing the amount of load that has been transferred to the cloud. So what it will do? It will first of all reduce the latency. It will increase the bandwidth optimization of the entire process. So the components required here will be edge gateways that are capable of performing edge computing, that is local processing of data. Then fog computing nodes. When data processing is performed away from the cloud and slightly away from the devices that collect it, in somewhere in between, in the middleware. We call it fog computing. So there will be fog computing nodes, fog computing devices. Further, microcontrollers and embedded systems will be required with processing abilities. So to enable this entire thing, the data processing at the edge side, we will be requiring some microcontrollers as well as a part of embedded systems. What are the various functions performed by it? Pre-processing of data. So instead of cloud computing, we are processing the data at an early stage. That's why we are calling it pre-processing of data, and filtering of data before sending it to the cloud. Real-time analytics can be obtained through this, and decision making at the edge can be done. So instead of waiting for the data to be reached over to the cloud and some decision to be made or some insights to be drawn from it, what we are doing is we are performing some kind of local data analysis at the edge only, and that's why real-time analytics is possible. It will reduce the load on the cloud services and minimize the data transfer cost. So instead of transferring the whole data, we are transmitting the data intelligently now. We are processing it and then transmitting it. So it will save the bandwidth, it will save the transmission costs as well. So this is the third layer called edge layer or processing layer. Then we have data management layer or the middleware layer. The data management layer serves as the bridge between the connectivity layer and the application layer. Okay. So between the data transmission layer and the upper application layers, there will be a data management layer. It will manage the data integration, storage and processing, enabling smooth communication between the different IoT components. So when we talk about the IoT applications, IoT data plays a very important role. IoT data, because at every step, enormous amount of data has been generated, it has been collected. So storage of this data, management of this data, efficient processing of this data, and analytics to derive meaningful results. These all are the very important parts of an IoT application or IoT ecosystem. So data management layer is the middleware layer. It will perform all these tasks for you. And the components that it will require are middleware platforms for data processing and storage, data brokers and aggregators, data aggregation techniques can be applied over it, API management tools. API stands for application peripheral interfaces. So application will interact with peripherals through these tools. What are the functions of this layer? Data normalization and transformation, integration of various data resources, managing communication protocols and interfaces. So basically all your data management related activities, starting from storage, from management to processing, all it will be managed by your data management layer, the fourth one. Then we have the application layer. Application layer, you know, the application layer is where the user can have interface with the IoT application. So the application layer, it includes the software applications that deliver the services to the end user based on data collection and process through IoT architecture. So whatever the thing has been done, whatever data has been collected, whatever processing has been made, finally some results will be there. Finally, there must be some way to connect the end user to the IoT application. So there is an application layer that will connect the end user with the IoT application. It is responsible for turning data into actionable insights. Okay, so when we are having a user interface where the user can interact with the application, it will convert the entire application into some actionable insight. What are the components required? Mobile and web applications through which the user can connect with the application. There will be analytic platforms, data analytic ke platforms honge, control and monitoring dashboards. So it is the visualization part, data visualization part from the user, from where the end user can connect to the application, can monitor the entire data, can visualize the data and can take meaningful actions. What are the functions? It provides the user interfaces for interacting with IoT systems, executes automated actions based on data analytics, delivers notifications, alerts and reports. So whatever is associated with the end user, Okay, so end user will be connected to the entire IoT application through this application layer. Next we have on the top of application layer, security layer. So what is security and why it is so important in IoT? When we talk about IoT or the IoT applications or the IoT networking architectures, it has been seen that we are transferring enormous amount of data to internet. There is a role of internet, there is a role of connecting or pushing the data over to the cloud. So whenever we are pushing the data over to the internet, there are always security breaches, there are always cyber security reasons that we have to take care of. Okay, so security layer is very important. It is a cross-cutting concern in IoT networking architectures. It includes, it will drive or it will take care of all those measures to ensure data privacy, integrity and protection against unauthorized access. Okay, so when we are talking about IoT applications, we are using the internet, the entire cloud. So there are the very major concerns of security, and there is a layer which is needed to take care of all the security aspects. Unauthorized access should not be there. Any kind of data breaches should not be there. What are the key components required? Encryption mechanisms. Data encryption means we are converting the data into a form which cannot be recognized by the unauthenticated user. Third party breaches वहां पे ना हो, उसको रोकने के लिए हम डेटा को encrypt करते हैं. Authentication and authorization systems. Only the intended recipient can have authentication or authorization of something. Okay. Firewalls and intrusion detection systems are used to ensure the security layer, to ensure the security of the entire IoT ecosystem and the data, the networks which are behind it. What are the functions of security layer? It secures the data at rest, in transit and during the processing, manages the devices and user access controls, detects and mitigates security threats. So basically, it is a very important layer when we talk about security of IoT data, IoT networks. It is there to ensure the security of the entire IoT ecosystem. What are the, we have studied the entire IoT networking architectures including 6 layers now, beginning from the first layer, that was a device or the perception layer, whose role is to collect the data. Then came the networking layer, whose role is to transmit the data collected to higher layers. Then is the edge layer, whose data is to perform local data processing. Then we have data management layer, the fourth one, whose role is to manage the entire data collected in the entire system. Then we have the application layer on the top of it, from where the user, the end user is connected. It is having an access to the entire IoT application. And finally, at the 6th point, we were having security. So security layer is important to enhance, to ensure the overall security of this entire IoT ecosystem. Next, we have the features of IoT networking architecture. First is scalability. So when we have a well-defined architecture, this architecture should support scalability. It means scalability in IoT means that we can increase the number of users, we can increase the number of nodes without affecting the performance of my entire system. So it should support a growing number of devices and increased data loads as the IoT network expands. Whenever the IoT network will expand or the number of nodes will grow, there should not be any issue of performance. That is called scalability. Second point is interoperability. So interoperability, it stands for compatibility between different devices. Okay, so interoperability is again a very important part, and different IoT devices and systems must be able to communicate among themselves regardless of the manufacturer or technology used. As you all know, IoT is a big ecosystem comprising of different heterogeneous components. So these components must be able to communicate among themselves. They must be compatible, must be interoperable. Next, we have reliability. Reliability means the network should provide consistent performance with minimum downtime, especially in critical applications. So the entire IoT network should be very reliable and it should maintain its consistency, its performance. Low latency. Obviously, in this fast pace, we want the applications to run fast as possible, the data to be transmitted as fast as possible. Therefore, low latency and real-time applications is the requirement for today's scenario. So your IoT networking architecture must support all these key important points: scalability, interoperability, reliability, and low latency. That means low delay. Finally, the challenges. Well, the challenges associated with IoT networking architecture are security vulnerabilities, as we have already discussed. Whenever there is a talk about IoT or connecting the data to the net, there are always security breaches. So security aspects will be there. Data management. Second one, since enormous amount of data is collected from the various IoT spots, from the various IoT layers, data management is again a very big challenge. Interoperability issues. Obviously, they will arise because there are various different type of components which have been placed at the various layers. So, in order to maintain the compatibility between them, in order to have a seamless flow of data over these devices, interoperability issues will arise. Bandwidth constraints. Bandwidth constraints will arise because the networking protocols, they have a limited amount of bandwidth and the data is enormous. The data is enormous and we have a limited bandwidth supply. So, there will be issues for bandwidth, etc. So, these all are the challenges associated with IoT networking architectures: security issues, data management, interoperability, and bandwidth constraints. Finally, we have arrived onto the applications of IoT networking architecture. So, IoT networking architectures will find application in various areas, including the smart cities. As you all know, there can be connecting traffic lights, surveillance cameras, waste management, and more. These are some of the examples where IoT can be used in smart cities. Industrial areas, industrial IoT, it connects the machines, sensors, and control systems in manufacturing. Okay, so human labor will be reduced, automation of things will be done when we apply IoT in industries. In healthcare sector, it can be applied because remote patient monitoring can be done, smart medical devices, real-time data analysis can be done for patients. So, e-health or healthcare is also one of the important areas where IoT can be applied. And finally, agriculture. Agriculture, today we are applying a lot of IoT applications and products. We are deploying them in the agricultural fields. So, it can be done, it supports precision farming by connecting soil sensors, weather stations, irrigation systems to optimize crop yield. So, these are the various areas where you can apply the IoT networking architecture. So, that's all about today's lecture, in which we have learned the various layers of an IoT networking architecture. 6 layers are there. What are the key roles or responsibilities of them? What are the challenges associated with them? And what are the application areas where we can apply them? So, thanks.